Hello everyone. My name is Ncube, current president of Zimnog. Thank you very much for joining us today for this future internet event. We are going to be having two of these events this month. We'll start with this one today. We'll have another one probably in the next 2 weeks. Right, so in these events, you get a chance to interact with some of the specialists in the Internet of Things domain. Internet of Things being a disruptive technology, which I'm sure most of us have heard about it in our spheres. This is a disruptive technology which is changing the way that we've previously perceived the internet. Right, maybe I'll start by introducing Zimnog. For those who don't know Zimnog, Zimnog is a community of people, a voluntary community of people in the field of ICT. Anyone is welcome to join Zimnog. You can be an engineer, you can be a technician, you can be a professor, you can be a student, or you can be a general internet user. You are all welcome to join Zimnog. And because we're an open community, we value the views of different people. We appreciate contributions from different people. So we are going to be sharing a QR code during the event. Please make sure that you scan it. You can download the QR code scanner. There are some applications online that you can use. Some phones, they come with inbuilt QR code scanners. So you can download it, and the moment you see that that QR code, you can snapshot, you can scan it to take you to a link where you probably complete a form, a general review of the event, how you think we should improve, any comments that you might have. We'll also put a link on the side, on the comment section. On that link, you can also follow it, and then it will take you to the same form. And then in the end of the event, we'll do a random selection of those who would have completed that form. We'll do a random selection, and then whoever is selected, we'll try to show it on the screen as we do that random selection, so that whoever is selected can then get a small gift just to show appreciation. Right, today we are joined by an IoT evangelist. We are joined by a strong proponent of disruptive technologies. He's a strong advocate of entrepreneurship in the domain of Internet of Things, machine learning, big data, and artificial intelligence. He holds a PhD in electronic engineering, and he has done a lot of work in Internet of Things, specifically in wireless, in virtualized wireless sensor networks. I know most of us, we have heard about it, but today we are going to be getting information from an expert. He's a founder of a company called Hailer, an e-hailing platform or company that has captured the interest of many people in the region. I'm sure if you probably have heard about it, or if you go on the internet and you just Google Hailer, you see it. His name is Dr. Marlvin Nkomo, and he's going to take us through how the internet has changed over the years, what we are to expect in the future, and in general, some of those things. So I'll hand you over to Dr. Marlvin Nkomo so that we don't waste much of the time. Please remember to check the QR code as he does his presentation. Over to you, Doc.
Good evening to everyone. Please just confirm that you can hear me.
I can hear you, but my students can't hear you.
Me, I can hear you this side.
Okay, no, that's fine. I just wanted to confirm the sound, if at least I'm audible enough. I'm not so sure on the other stuff. And I would also request everyone to at least mute their mics. That would make our life easier. Can I?
Sorry, say, my students can't hear you.
I can, sir.
So are there some people with challenges hearing?
Yeah, someone called Oluchi, she's having challenges hearing you.
Okay, okay. Maybe if you've got challenges with anything, you can probably send a direct message to Mfano Figile Ncube or Nomsa Mwayengwa, sorry, or Cuthbert and Open. You can send a direct message there. Then we'll see how we can assist you. Okay, over to you, Doc.
Figile, can you see my presentation?
Yes, I can see the presentation.
Okay, no, that's fine. Yeah, thank you so much for the opportunity to invite me to talk about what I believe is actually the future, not just the future, but something that's already happening now. And there's a lot of loose talk around about the Internet of Things, artificial intelligence for the Industrial Revolution and everything. So I'll try today to at least scratch the surface. Unfortunately, the work that you're seeing here is not just the work of a few days, but it's been a work that has spanned years, if not decades, on my side. And I'm seeing a lot of my fellow, ex-varsity friends. Hi to everyone. And I can't mention names, all them by one by one. But what I'll try to do today is to just give you an appetizer type of thing when it comes to where the future of the internet is heading to. And if you're not in this internet bandwagon and revolution, chances are you will be left hanging along the way, if not replaced altogether by systems that will come into place. So our talk today is entitled The Future Internet, And the subheading that goes into all of that is Virtualized Wireless Sensor Network for Heterogeneous Internet of Things applications. I know some of these terms are very much new to some of you, but some of them are very much, it's like, daily bread, So in the audience, I know there's a mix of very technical people and non-technical people. So I'll try to switch between both worlds. So if I don't really go into the depth that you have loved to as an electronic engineer, data scientist, you're a computer scientist, and networks guy, don't worry, I'm doing it in the interest of everyone else who has joined in all of this. So what I'm going to talk about, I've got 6 talking points. They look up, they're quite brief, but on my slides, it's more detailed. So the first thing that I'm going to look at is the history of the internet, very briefly, because of time limits on my side. And then in a short space of time, also, I'm going to look at the Industrial Revolution. Everyone is talking about the 4th Industrial Revolution. So I'm just going to try to do justice in the few minutes that I have. And then IP version 6, I'll explain what that is. Then I'll go into the Internet of Things. Then the new Internet Protocol, which is an extension of, which will be more details on this new protocol that is sweeping across the world over. And lastly, I'll talk about something that I believe is the future of wireless sensor networks, which is virtualized wireless sensor networks. And to start off with, most of us now are connected to the internet, and we should thank at least these 2 gentlemen, Bob Kahn and Vince Cerf, who we recognize in the tech world as the fathers of the internet. By the fathers of the internet, these are the guys who designed the internet. Sometime in 2011, I attended a session where Vince Cerf was presenting about the internet. And this thing really captured and intrigued me so much, to the extent that I kind of like, took a U-turn altogether and said, look, okay, cool. This is actually the future. This guy presented what I believe was really amazing. He's working at Google at the moment as the chief IoT evangelist. So he speaks basically about IoT and where technology is heading to. So he introduced to us what we have now as the internet, And one of the most exciting things that he said in that talk was when they designed the internet, he says, look, when we designed the internet, we designed the internet without Google, meaning to say he had nowhere else to search for information. And this generation is so very lucky because at any given time when we are stuck with knowledge and you need to learn something, you quickly go to the internet. These guys didn't have that kind of opportunity. They didn't go to the internet because they didn't go on Google because Google was not there, because the internet was there, because Google is an overlay service on top of the internet. Now, so you will realize that the internet was first created as an overlay service on top of the existing telephony system. What does it mean? What does that simple mean? It means for the internet to exist, there was the telephone system. I'm sure those that are old enough would relate to me that we used to have that, for back then when you needed the internet, you needed to have a telephone line at home, dial up and everything. So the internet was an overlay on top of that existing internet telephony system infrastructure. But now we are starting to see the telephony system being an overlay service on top of the existing internet infrastructure, which to me spells out an evolution of the internet technologies that are out there. When I was we speak about a voice over IP, and which in actual fact is the voice over internet. I mean, voice being transmitted over the internet. So when you look at history, there's been an interesting wave of technological advances and changes that have kind of like shaped where we are now, where we're going, and all the other confusion that is, met us in the way, And if you're a student of science, you would understand that technology started with the threads of, say, Isaac Newton, James Watt creating the steam engine, which was like more of a knowledge formulation era, and they started doing mechanization, making farming easier using machinery. And from there, we started seeing, advances in technology coming in the form of electromagnetism, which gave birth to electricity, and that stuff started happening faster, and we started seeing homes, areas, factories being electrified, and with that, there's mass production of goods and services. So the first part that I spoke about was the first industrial revolution, the mechanization of the farming industry. Then from there, we went over to the second industrial revolution, which was more of a knowledge evolution kind of era, where scientists started coming up with very disruptive ways of getting things done. Electricity came up, and over time, I mean, 60, 70 years ago, there's the third wave of swept across with the invention of the transistor. So the transistor came, and it became the basic building block of everything that is somewhat computerized at this day and age. And it's unfortunate that 72 years after the invention of the transistor in Africa, we still don't have a single company that manufactures silicon, And these are the opportunities that I always say to people. We need to find ways of getting most of these things done, because in Africa, we are the biggest producers of coltan, and that goes on to manufacture most of these silicon-related products, And because of that, we started seeing computerization. People started using computers. People started having emails and everything. And because of that, we started having an opportunity to connect to people far and wide, quicker and faster in a way that we initially didn't envisage. But now we are starting to get into another era that is somewhat more exciting than all these other eras, which is the fourth industrial revolution. Now, the fourth industrial revolution is not something totally new. It is, I would say, a mutation of all of the technological advances that have happened throughout the years. The issue of the GPS is not a new thing. The issue of data is not a new thing, but the coming together of data and systems have given rise to what we believe now as artificial intelligence, and we're starting to see a cyber physical systems coming together, starting to interact together, and by so doing, we start to exist in the same space as robots. Certain jobs that wouldn't have been otherwise done by humans are now being done by robots. And a lot of people are very scared now that robots are coming to take their jobs. And we're simply saying, no, look, they're not coming to take their jobs. They're coming to take what is somewhat redundant. So it is to everyone's advantage to upgrade themselves. And we talk about disruption in money. We talk about blockchain technologies that have given birth to Bitcoins and all of these other things, artificial intelligence, the ability to do work quicker, faster, and easier. But more interestingly, today, I am going to focus mostly about the Internet of Things, and I'm going to explain what that whole value chain talks about. So, and we all roundly agree that for us to get to where we are, the bulk of all the advances that we have at this day and age has been largely spurred by this place called Silicon Valley. Silicon Valley is a place in California, in the Bay Area, somewhere in San Francisco, and this is where where all the big tech companies are housed. And I would like you guys to look for the book, The Intel Trinity, by a guy called Michael Malone, right? And he details the history of the three guys who actually founded a company called Intel, right? I'm sure most of you guys with your laptops, it's always written Intel inside, right? Then someone jokingly said, Intel inside, idiots outside, which is a more striking, representation of everything else that is happening. If you are not tuned into with all the technological advances that are happening, you might find yourself somewhat confused. At this day and age now, COVID hit and struck everyone, and we still continued living life. Why? Because of the advances in technology, and silicon started to become a very, very important part of everything else that we do. And Gordon Moore, Robert Noyce, and Andy Grove started this company called Intel. And it is them that started. So they went to Silicon Valley and they found a peach farm. It was like just a farm. They said, okay, cool. Tear down all of these down all of these trees and we're going to start a company. It was something very strange, because California was a heavily farming area, and they had to tear down the whole place, and they started what we today have as Silicon Valley. This is where all the tech is actually happening, right? And of course they go on to postulate that, okay, over time we're going to start having a lot of transistors in a circuit, and this is actually going to become smaller and smaller and smaller, and we're starting to see that with computers. Computers traditionally use ones and zeros, which is like binary, but that on its own is not even enough. The future internet demands would mean that we need to extend processing of information beyond ones and zeros. That's where now we're starting to talk about quantum computing, which is the future of computing. Quantum computing helps us to at least image and process things in multi-dimensional using at least two methods, superposition and entanglement. Everyone was talking about entanglements a few months ago when Will Smith and Jada came out, but the actual entanglement happens inside the future computing systems. So then we start all of a sudden, like back then when we were at college, I remember there was just a few people with cell phones. Why? Because the mobile internet was not yet a big thing. But now everyone has got devices. I mean, usually at my desk at any given time, I've got 3 or 4 mobile devices. So the proliferation of mobile internet has actually given rise to all of these connected devices. Everyone is starting to be connected, and all of these devices are starting to help us ask very pertinent questions about what is the internet taking us to? And interesting enough, I'm a huge space fan, like I'm sure most of you know that, like I'm a huge space fan. Now, 1969, NASA launched, Apollo 11, successful landing on the moon, right? The circuitry and the computational power that they have in that rocket that took men first to the moon is far less superior than the technology that you have now in your phone, right? Meaning to say that we have got far more greater computational capabilities in our pockets than the technology that took men first to the moon. This is the magnitude and the extent with which technology has advanced, and we start coming to this whole concept of the Internet of Things. What are these Internet of Things? Now, I'm going to skip a few slides here and start to talk about. I'm going to come back to all of these slides, right? Now, remember, traditionally, the internet started off as a military project, right? And then from there moved in by the business world as a standard communication tool, started having the email services coming up and everything. Then after that, it has been somewhat absorbed by, the millennials over social media and all. And because of that, there's a huge stream of data that is flowing over into the internet, right? So think about this way. Think about the core internet infrastructure as an onion ring. So if you look at the picture that I have now on my screen, right? So the core internet, the core and the backbone of the internet is composed of millions of nodes. These are like your supercomputers and everything, all the big computers that help us to be somewhat connected, all these big servers and everything. Then the range of these devices, when you were to enumerate them and if you were to count them, they range in the region of millions, right? Not the magnitude. They range in the magnitude of millions. Then we've got what we call the fringe internet. The fringe internet is all of us who use the internet via our computers and everything, right? Then we have got what we call the Internet of Things, right? The Internet of Things now is an extension of the traditional internet to items that are somewhat inanimate, items that were not included into the internet and that were somewhat marginalized. And these are the things that, just imagine connecting yourself to your curtains, imagine connecting yourself to your hi-fi system, you're connecting to your system in the toilet, So this is the extension of the internet that is actually sweeping across all of the the technology world. So we start to seeing smart buildings that have got, you can monitor a building remotely, whether it's fine and everything. We're starting to have cell phones now. All of us, on average, everyone has got a cell phone. We're starting to see everyone these days has got a personal, tracking device on their hand. We're starting to see logistics being, with the emergence of your Ubers and your Hailers, your Taxify and your thingy. We're starting to see technology and the internet filtering into all of these things. The ability for us to have all of these services is because of the extension of the internet to items that we call things on the internet architecture. And we're starting to see a lot of industries being automated and smart metering. I'm sure most of you now, especially here down in Johannesburg, South Africa, people buy water, via their phones. Buy water via the phone. It gets loaded onto your thingy, onto your meter, and you can even order your electricity via your mobile phone, and it goes onto your meter and you top up and everything. That's smart metering, So there's a lot of smartness that happens in this day and age. And what has made us to be able to do that, So in times past, in the technology space, we used to talk about what we call machine to machine, So now I'm actually trying to talk about the evolution of M2M to IoT, So there's a lot of connectivity that happened back then, whereby you could connect your system your car, you connect your car to a back-end system, BMW connects to BMW, Mercedes-Benz connects to Mercedes-Benz, you know. But now with Internet of Things, you know, everything else is connecting. Services, you know, the web and things, you know, are connected, you know. So if you see where we're moving from a siloed approach to a more federated and an open architecture, which is the thing. And we're moving from basic smartness to advanced smartness. And if you see now, at the moment, when we're talking about wireless sensor networks, what is it that we're talking about? We're talking about a configuration of nodes. Now, I'll explain what these nodes are. Nodes are basically small embedded systems that are that help us collect data, you know, from different endpoints. You know, this could be your temperature, your humidity, your acoustic data, your seismic data, your velocity, your acceleration, all of those items that you're actually gathering and collecting, you know, using those sensors, those actuators. You get them, you put them into, you've got your microcontroller, then that takes, that does the computation locally. The microcontrollers, they've got limited space and computational power. So what they push that to a sync node, which is basically a gateway. A gateway takes that to the what? Takes that to the internet, and the internet, you've got this cloud infrastructure that is able to at least do more computation onto it, and end user can consume whatever data that comes out of this as information, not as data. Or so this is the basic architecture of a wireless sensor network. So there are three things to note. You've got a node, you've got a sync node, you've got a node which is your sensor, and you've got a sync which is your gateway, and you've got your core internet infrastructure, which is where you house all your big data, analytic stuff, your storage, your computation. Then, of course, you've got your end user, right? And the second part that so I've explained to you what a wireless sensor network is, you know, though it's, you know, it's very basic to a lot of us, you know, and the wireless sensor network, right? So that's the wireless sensor network. We look at it from that perspective. Then we talk about the second part, which is heterogeneous. Now, hetero means two. I mean, two or many, you know. So when you're talking about heterogeneous wireless sensor networks, we're talking about wireless sensor networks of different size and of complexities. Now, remember, sensor nodes have got different capabilities. The first capability of a sensor node, there's actually three items that you need to consider when you're building a wireless sensor network. The first thing that you need to do is consider the computational capability of that node. How quick and urgent can you process the stuff? Number two, the storage. After having stored that information, after having processed that information, are you able to store that information, yes or no? If the answer is no, then you need to look for somewhere else to store that information. Then the third thing is the communication. So after having gathered the information, processed is, you need to relay it to the next space, you know, next node or next gateway or storage facility and some sort. So with the gateway, with the wireless sensor network, you start seeing nodes that have got different capabilities there. These nodes have got different computing, communication, and storage power, right? And because they are different, you know, they all don't come in the same way, you know. So as a sensor that measures temperature is different to a sensor that measures surveillance, you know, because surveillance needs more storage and needs more computation. It needs better communication to the thingy, and latencies could come in again. So when you're building and architecting your wireless sensor network infrastructure, it talks to those kind of complexities. So when you're looking at those three items, you are building what you believe will be able to take whatever information to where you want it to be. So in this case, with sensor nodes, these sensor nodes are of different capabilities. That's why we say they are heterogeneous. You know, we mean to say they are quite complicated. You know, they are quite robust. They are able to do things in different spaces altogether, right? So here's an example of a heterogeneous setup. You know, so you could build a smart factory or a heterogeneous you know, arrangement. You know, this could have magnetometers, you know, sensors for the roller system, biohazards, air conditioners, emission sensors, waste, fire, emergency services, transportation and logistics, turbines in industries, surveillance, water leakages, you name them. This could be like a wide range. So when you're talking about heterogeneity, we are talking about this layer of the wireless sensor network, which makes wireless sensor networks difficult. So when you're talking about wireless sensor networks and how complex they can be, well, we are addressing this layer that gives us this kind of heterogeneity, right? I'm going to come back to this slide. So, and because of that, we traditionally, when the internet was created, right? So internet when the internet was created, each and every device on the internet is addressable. I just put it in layman terms. So each and every device on the internet is addressable. What does that mean? You know, all of us here, we've got home addresses, and that home address is unique to you. You know, no one can claim that this is their address when they don't stay there. So each and every computer on the internet is addressable. Each and every participant on the internet is addressable, right? So when the internet specification came out, the IP version 4 came out, right? We could only address up to 4.3 billion nodes. What does that simply mean? It means that those the items that can participate on the internet had a limit, you know, of at least 4.3 billion devices. So if we get to 4.3 billion devices, we can't add more devices onto the internet. And that day will come, September 2011. September 2011, we addressed the last node on the internet on IP version 6, right? But interesting enough, this was 2011, right? But as early as 1993, right, there was a team of the Internet Engineering Task Force had summoned a team to start to look at the future of the internet. Now, look at this. This is very interesting to me. I mean, in 2011, we had already started saying that the internet address space, well, by 1993, when internet was not even a big thing here in Africa, right? The engineers and the people who were researching about the internet had already started saying that the internet address space is going to be exhausted. So let us start being proactive and work on the next specification. Now that specification that they started working on in 1993 turned out to be IP version 6. Now, IP version 6 simple spelled out this to us. It simply said that from a 32-bit address space, you know, now we are getting to a 128-bit address space now. The capabilities of the 128 address space meant that all of these items that were on the fringe of the internet can now participate on the internet, right? Why? Because they can be addressable, right? And because of that, we are able now to address a chair, you know, a table or anything that we can actually think of, you know. And that draft specification came out 1990. By 1994, it was out. And there's a guy called Christian Wutitema who worked on that specification. And it was very interesting to see that how futuristic these guys are. And the question that I always ask myself to say, okay, cool, these guys saw it as early as that time. What is it that we're doing here in Africa that helps us say, okay, cool, this is the future, this is where we're going, what is it that we're working on? That's why we're always consuming, you know, like that's why your top 5 apps on your phone, they're all from Silicon Valley and none from Africa, you know. So we need to start innovating in this space because of the 4th industrial revolution and the opportunities that they have been presented to us, you know. And of course now, because of the Internet of Things, we're starting to see a lot of items starting to participate on the internet. And there's a lot of protocols. By protocols, we mean languages with which these small devices would otherwise be able to participate on the internet. I wish I had more time to actually talk about a lot of these things. And how do these devices enable us to be able to participate on the internet, right? So you'll find that most of these sensor nodes, you know, like we're back now from, we're not talking about the entire architecture, we're talking about the nodes. Now on the nodes, for these nodes, for them to participate on the internet, you know, they need to have at least communication, computation, sensor actuation, and storage capabilities, right? And most of them now, for them to do that, they use our operating system. There's a lot of operating systems that are out there that have been created to enable us to be able to let all of these things participate onto the internet, internet regime. So you've got Contiki, you've got Tiny OS, you've got Mantis, Open Open Wireless Sensor Network and Light OS. If I had time, I was going to go on and explain, and this is quite exciting stuff that you would otherwise learn from me. I'll share this whole thing, right? When you look at the existing internet protocol, IP version 4 and IP version 6, you can do a cross mapping of the protocol stack from IP version 4 and this one, and you can start to see that there's an introduction of what we call the IEEE 802.15.4 mark, which is a standard IEEE 802.15.4, right? A standard, right? This specifies the mark and the file layer of any of these devices that go on to participate into the internet, right? And this is on the data link and on the physical layer. You know, if I had more time, we're going to go into all of the intricacies of all of that. That's why this is one, just to get us going, you know. And if you take that and put that OSI layer at the center, you can see a direct transliteration of all of those things and how they actually pan out. Now, for you to achieve, maybe before I get to virtualization, now, if you go back to years back, you know, most of us couldn't afford multiple devices, like multiple computers. You know, I remember back then when we were at school, at high school, at varsity, you know, we started exploring the whole concept of virtualization, you know, which is running 2 operating systems on 1 device, you know. And a computer being a node, simple means that it can run 2 computers. It can run 2 operating systems, but 1 physical device. And the appearance of it will be such that it is that operating system is the only item that is running on it, because you're only seeing 1 interface, right? So the same approach and architecture can be extended and abstracted from the traditional computing and put into the Internet of Things, right? Because when we do that, we're able then to make Internet of Things more versatile and robust, right? So we start to see the different cores and the different architectures that could be implemented. You know, we've got an OS-based setup that can do multi-threading. They have got a middleware-based setup that can actually help you do the virtualization at the middleware level. And we have got a virtual machine setup that can just, you can run a virtual machine and all of that. Then you can run your different applications onto that. That helps you to attain to virtualization. Now, what is virtualization in the simple sense, right? So a lot of us now use what we call cloud computing, you know, which is, you know, your ability to use the computer servers and systems without you actually owning the infrastructure. You buy that server space. When you're done with it, you can cancel your stuff, you can stop your services, someone else can use it, right? So we are trying to extend that kind of approach from existing sensor networks and putting them onto the onto the internet, right? Onto the sensor nodes, right? By so doing, we're able then to make sensor nodes more complicated, more robust, and better service here. Because at the moment, most people can't afford to lay a sensor on themselves, do the software, do everything else, right? So you are able now to buy sensor space and use the sensors. And when you're done with the sensors, you let someone else use it, you know? So this is actually a more efficient way of getting it done, you know? So when you, one of the biggest constraints that we've had with the traditional internet architecture here, when it's extended to the Internet of Things, is that it is very robust and very big. So if you look at the web stack, when you want to put a web application onto a device, you can't do that, easily do that. Why? Because the whole stack is in thousands of bytes, you know? But then when you take that onto the Internet of Things backbone, you are able then to compress it to a few hundreds of bytes, right? But then even with that, it's still very bulky. Some of the computation and the storage space that you have in most of these sensor devices, especially the low-end devices, you can't even be able to do much. So what do? You then take that and condense it to a much smaller stack, which will be in the tens of bytes. So this is what all of these advances has managed us to do. And that's why now most of us can, even just from your phone, just from your wristwatch, you can answer a call. You know, think about it. You can answer a call, text from your thing, and respond to your messages just from your wrist. But you couldn't do that. You needed to get your phone previously, you know. So this is just the comparison of how that evolution actually happened, you know. So they have got different virtualization platforms. You guys, I'll share this presentation and you can actually look at it. You know, there's a lot of technical content that I'm not able to go through it at the moment, right? So we're seeing that virtualization is a solution to a lot of these challenges that we have in wireless sensor networks, right? So we see that the biggest hindrance for wireless sensor network at the moment is security. Now, this is very interesting, but because think about a situation whereby you've taken Internet of Things, your whole life is on the internet, right? If your whole life is on the internet, if someone were to hack into your bedroom, they will be able to see the surveillance camera and see whatever you're doing on the, you know, in your bedroom or anywhere, right? And because of that, we're saying security is one of the biggest hindrances of the full propagation of Internet of Things. Now, going back a little bit, I know Google is working on a concept basin chamber where, you know, like you go to your, you know, go to the toilet and all. So this chamber would take your waste, you know, your waste and your urine, urine and waste, so same thing. Yeah. So it will take your waste, instead of sending that to, because traditionally when you want to go to the doctor, maybe they would ask you, say, no, please bring us your waste or something, you know, we just want to analyze if you're healthy or what, or your urine, you know. I'm sure women can relate better than us guys. You know, when that happens, instead of you having to do that, you don't have to carry that waste anymore. You just go sit on this concept chamber. At the moment you flush, you know, just imagine everyone at home having that flushing system. When you flush, it takes that dump, it analyzes it, it sends it straight to your doctor, you know, and you see your results from your smartphones, you know. And because of that, we're able now to say we are fully connected and wired to the internet. And you don't, by the time you go to the doctor already knows what you're supposed to do. And in actual fact, you might not even go to the doctor, because the doctor will send the report to your nutritionist, who in turn tells you what to buy, you know, and you don't even need to go to the shops, because you will just order everything online and Hela will deliver it for you at home, you know, type of thing and all. So at the end of the day, you are living in a world where everything and anything is connected, you know, but the biggest issue is security. So Internet of Things now, for them to get to a place where we can trust them, we need what we call trusted execution environment. If I had more time, I was going to talk about this, you know. Then the second biggest issue is scalability, you know. How quickly can we scale these items? I'm not going to talk much about that, you know. Then the third thing is the quality of service, you know. Whatever sensor node you have out there, is it quality enough? You know, like, are you getting the best of it? You know, robustness. Robustness talks a simple thing where you are saying, how do you make this whole thing such that you are able to do almost anything on one item? How robust is it? You know, then heterogeneity. How many multiple verticals and horizontals can you do using one device? You know, then we start coming to this concept of overlays. Now this concept of overlays is the one that enables us to be able to achieve most of these things. Unfortunately, I don't have time to talk much about it because of gone. So these are the challenges that we have in wireless sensor networks. You know, real-time performances, advanced node virtualization, application and discovery. I'm not going to talk about that. Simulation tools. I wanted to do a simulation if I had time. I was going to show you how you actually model a sensor network, you know, get it to communicate to different stuff, how you can do stuff and everything, you know, task and sensor node assignments, evolution of the frameworks, abstraction support. These are the challenges that you, when you're building your Internet of Things service, these are things that you need to address first before you can actually build the thing, you know. Energy efficiency, security, resource management, process scheduling. You know, most of you guys are computer scientists, you know what I'm talking about here, you know, and how will this item that you're working with be backward compatible with new technologies? You know, like, will it be compatible with anything else that comes after that? You know, then of course, I mean, I'm going to skip with this, and I'm actually going now to explain how we actually attain virtualization in wireless sensor network. So in virtualization of wireless, so now we're not talking about this wireless sensor network that is happening now. We are talking about the future of wireless sensor network. When you talk about the future of wireless sensor networks, we are simply instructing and giving a mandate to every engineer who has worked on this thing to say, think about what you can do for your community, for Africa and the region around you, around alleviating challenges that could be easily solved by the Internet of Things. Why? Because we've got problems of urbanization. There's a lot of people moving over to the urban areas. We've got a lot of people needing services done more efficiently. People are losing their jobs. How do we create more jobs? How do we solve our issues of climate change, global warming? Can we deploy more sensors to measure temperature, humidity, carbon dioxide content and everything? So these are all the things that as engineers need to come and solve, you know, because until our engineering can solve real problems, then we're good as, you know, waste paper engineers, you know. So here is the future of wireless sensor network. The future of wireless sensor network is virtualization. Why? Because traditional computing has succeeded to this extent because it virtualized everything else that it was doing. If we take and abstract the very same approach and layer and architecture into wireless sensor networks, we'll be able to do that. But how do we actually do that? You know, I remember my professor, one of my professor used to say to me, Marvin, if you see yourself looking for something on the internet and not finding it, know that you're actually starting to do research, right? So when I was working on wireless sensor networks, looking at virtualization, I looked for virtualization up until I couldn't find the word virtualization linked to sensor network, right? So then I came up with this architecture whereby I said, look, okay, cool. If you have got a heterogeneous layer, right? And you take that heterogeneous layer and create a virtual layer in between it, where it starts forming a fog network, you know. Let me look for a thing here. Okay. So you take a visualization layer in its heterogeneous state, right? Then the first layer, then from there you create a logical linkage layer that is comprised mostly of gateways, and you use those gateways to help you do edge computing at the edge of the network, so that you don't have to push everything to the cloud. Because the more you push everything to the cloud, the more power you consume, and your sensors are going to knock off, right? So you start having a situation of this nature, right? Whereby from all of your sensor nodes, right, your sensor nodes start becoming very much available to be used by other people. So think about the situation whereby you want to access the camera systems of the traffic system in Joburg or whichever city, right? But they will tell you that you can't access that data. Why? Because you didn't install the cameras now. But with the virtualization, you can say, look, okay, cool, let me run my instance on top of that infrastructure and get that information and bring it to me, right? And by so doing, you are able then to share the sensors, right? So we are moving to a paradigm where we say sensors are now used as a service. So sensors stop being sensors from the traditional sense where they're only owned by one person. So traditionally, wireless sensor networks have been limited to a single domain, but now we're able to extend it to different domain, you know, different domains. Why? Because people can run their applications. When you're done, you go back and roll back your services. The very same way cloud computing works. And by so doing, we start having this fog layer, which is a very compute intensive and an intelligent layer that we can actually use to process stuff on the edge of the network. Think about the future of cars. Now, the future of cars is autonomous cars, right? So you can't have an autonomous car driving, and when it's about to hit something, it needs to send stuff onto the cloud to process, then it comes back so that it makes a decision. By that time, the latency involved in that communication, you would have hit someone, So what do? You process things at the edge of the network. So we start saying combining virtualized sensor networks and edge computing, and that forms a fork network. That fork network will be formed by the next available car that is actually going through the same thing altogether. So you've got your your sensor networks of your car and your sensors in your car, right? Then from there, the other car next to you can tell you that, no, you're about to hit the other car, so don't hit me. So this is actually happening at the fork layer, if you know what I mean, you know. So developers, system engineers can actually start working and building technologies and exciting stuff on top of that, you know. So so here's actually the architecture showing. This is an architecture that I proposed. It's available, open access in the journals, you know. So it talks about how these logical linkages are actually done. Unfortunately, I don't have much time to actually go into that. But what this thing was trying to solve, it was trying to solve three things, right? The first thing was trying to save power of sensor networks. Then the second thing, it was trying to save the latency, right? And then the third thing, it was trying to federate wireless sensor networks so that they can be used by almost anyone, you know. So by that, and with all the results and the simulations and the actual work that was done, proved that this whole thing can actually be done in the whole thing, right? Unfortunately, I don't have time. I was actually going to explain how this node and this architecture is realized, you know. So those are actually the steps and everything, right? So this is actually the architecture of that node. So what you do is, on your sensor node, you run a Linux kernel, you get a hypervisor. In this case, I use RTZen, and from the RTZen, instead of having one application running, you've got multiple applications. You can see from A0 to AN, you know, you could have a lot of those. You have maybe your operating system to help you do a lot of proto threads in there that helps you differentiate between the different applications. Then, of course, from there, you've got this edge layer that helps you know what to process locally and what to push to the cloud, because there's a decision that needs to be made instantaneously where you're saying that when the data comes, do I process this data local or do I to process this data on the cloud, you know? So when that data happens, so on the architecture there, you've got that edge forker and accumulator. So it accumulates data, then it forks data. Then after forking data, it says, okay, I'm processing this on the cloud, I'm processing this locally. If it's locally, I'm processing, I'll use an in-network analyzer to help me do these things quicker and make a decision and get going. Or if it's not that process critical, send it out to the cloud for more analytics and everything. Of course, the whole thing needs to be available on the web. So there's a network stack that helps you to do all of that. So this is actually the architecture that helps us take Internet of Things to the next level. And by so doing, we're able then to solve more pertinent, critical questions about the future of technology. And by extending all of these things to young engineers, brilliant minds, who are then able to help us innovate faster, quicker, and in a better way. And who knows, the next billion-dollar company will come from the African soil. It has to happen. Why? Because we know the blueprint of where the fourth industrial revolution is taking to. Now, the unfortunate thing about the fourth industrial revolution is, in Africa, we're talking about it, but the rest of the world is doing it and is not talking about it. And so it's time we start taking a lot of that a notch higher to help us to do that. Unfortunately, I'm not going to talk about all of this. I'm not going to talk about this and routing protocols. What routing protocols can we use to help us innovate and be fast and more robust platforms on the thingy? You know, so this is just a simulation. So here I use Contiki to help us analyze. You know, this is a wireless sensor network, right? That was using an overlay architecture where you've got so all of that you're seeing there are sensor nodes, right? Sensor nodes communicating back and forth. You can actually start to see the traffic and everything. So when they're busy communicating and doing all of that stuff, what you're simply saying is you're able then, before you even deploy your stuff, you are able to test that. So one of the biggest challenges that we have in us being able to innovate faster and quicker is that we don't have enough simulation tools to simulate most of these things. Then from there, of course, I mean, that was just a 10-slip connection that helps us understand how you actually connect that. And this is just C code and it just connects the thingy. Then the next thing that we needed to address about this whole Internet of Things and the future of it is congestion. Why? Because when we have a lot of devices are connected to the internet, we start having a lot of congestion. And how do you solve congestion? And this whole architecture that is virtualization of thing actually helps us. So from those 3 points, you can actually add the other part, which is congestion, network congestion. And you can see now, this is just a wireless sensor network. And you can see at the bottom there, you actually start to see those red spots that shows us how congested our network is. But when we apply virtualization, we start to see that whole thing being spread being spread, and gives us an improved module of how we can even visualize congestion, because we don't want a very congested system that we end up having. Like I'm sure you've seen, in simple terms, congestion is you're at a stadium, watching Orlando Pirates playing, Kaizer Chiefs, and you're trying to get onto the internet. Your internet is just struggling, so your node is not able to, in simple terms, like there's so much congestion, network congestion. So how do you even solve that? So by virtualization, we actually will improve that. You can actually do all of that. And of course, the biggest, simply most important obstacle of wireless sensor network is power. Power is everything. Without it, we can't communicate stuff. Without it, we can't do anything. And because of that, we are simply saying that by virtualization, if you do a power trace analysis of a sensor node, any sensor node. So here I was actually doing a sensor node analysis of the power consumption of all these nodes that are virtualized, and you can actually starting to see that because of that. So you spend more. So when you're doing wireless sensor networks, right? When you're processing, you use less power processing than power that you use when you're transmitting. So you're better off processing things locally, right? Than sending them out to be processed somewhere else, right? So when you send them out to be processed in the when you send them out to be processed in the cloud, you're using more power. So you try to avoid sending things to the cloud, because the more you communicate, the more power you drain on your device. So here was just a thing that shows that each and every sensor historical, that this is how it should perform if it constantly thing, Then of course, here with all that handshake that happens between your sensor node and your server systems and how that whole thing. So how I implemented this from the simulation part, I had to go on and implement it in real life. So I used the Raspberry Pi, and I connected a Launchpad CC2650, which gives you a much robust IEEE 802.15.4 stack that enables you to use these IoT protocols. Then from there, I use some CC2650 sensor tech nodes that have at least about 14. They've got about 14 sensors in there, and from there I could, so that was my setup, this thing was connecting there. Then you can actually starting to see this was the information being split off out of every node. And as I was taking these devices and moving to other places, you can actually see the signal strength, attenuation, the latencies change, and the power consumption change as you're moving the distance, because the distance is inversely proportional to the energy consumed, inversely proportional to the thing, the distance and everything and all, so some of those stupid unnecessary formulas that happen and everything. So power is a big thing, so this is actually the results that you actually get out of the whole thing. Unfortunately, in the interest of time, I'm not going to explain, but this was actually going to give you fine detail of how that whole thing actually happens. And I will skip, and that should be fine. Thank you. Hello.
Hey, thank you very much, Marvin. That was very, very insightful.
Thank
You've
you.
taken us through a journey all the way from the history of the internet, breaking down the protocol stack, giving us insights about security, robustness, and a lot of details. And I'm sure our audience has lots of questions. And if you do have a question, you can, at the bottom of your screen, you'll see a reactions icon. You can just click on that, and then we'll give you a chance to ask Dr. Nkomo your questions. So you can go ahead, let us know if you've got any questions, and continue to give us some feedback. Our feedback form is at the chat section. So continue to give us feedback. Okay, we will be starting with Tesh. I'm just going to allow you to unmute yourself. Hold on. Okay, you can go ahead, Tesh.
Can I stop this? Yeah.
Good evening, everyone. Doc, thank you. It's been an interesting talk. I'd like to zone in. Sorry, I'd like to zone in on the portion of that you mentioned towards the end, Africa and Africa doing these things and not just consuming them. How does Africa how does Africa achieve this? How does Africa get to the point where we are, starting to do these things? Are there any facilities within Africa that will allow someone to go and work on these things?
Unfortunately, I would say that there's a lot of work that is being done, but unfortunately, those opportunities, I believe I'm one person, I believe talent is everywhere, talent is everywhere the world over, but opportunities are somewhat limited. There's a lot of few people who are exposed to opportunities. The reason why some people are not yet at where they are at the moment in life, it's because opportunities have not been exposed to them, right? But here is my approach and my take in all of this. Now, I'm all for collaborative work more than anything else. The more we collaborate amongst us, just think about, the brains that are in this chat, the engineers, the strategists, the thinkers, the medical professionals that are here and everything, we can start teaming up as young people and building these services. Because when you think about how Intel started. It started with Andy Grove, Robert Moore and Gordon Moore and friends starting to build this whole thing that now we have as the Intel, and look at Facebook, Mark Zuckerberg and Sergey, Mark Hughes, Dustin Moskovitz, they teamed up with their friends, So the biggest single issue that we have in Africa is that we don't do collaborative effort in our work, So I might not know what NOMSA is working on. I don't know what CAPE is working on. I don't know what Kudza is working on, and because of that, we end up getting so boxed, If I think about, I see some of my former varsity guys here, if we started building collaborative work way back when we were in varsity, trust me, some of us will be running multi-million dollar businesses now. Why? Because all we did was finish varsity and go to work. And we sat on that treadmill for 10 years, we pride ourselves, 10 years experience and everything. But think about the 10 years you would have used to build your own business. Not just your own business, but a collaborative business with your friends, So it is time that Africa stands out and starts building most of these things by themselves. I believe there's a lot of talent. I mean, there's nothing amazing about Silicon Valley in terms of talent. The very same guys that you actually discover that you can actually go and work with Google and outsmart them. I was fortunate enough. I studied in China, and in my studies in China, I graduated on top of the world class. And so opportunities are the single biggest issue that we have, but we need to create those opportunities amongst ourselves, So I need to know what Tashinga you're working on. I need to know what NOMSA you're doing in your work, after hours, after 5, and I need to know what Kudza you're doing. And because of that, we're able then to do a lot of collaborative work that will help us to achieve most of these things. And there's a lot of cool ideas sitting amongst us, but you want to keep this to be your own idea, I've said away with that, open up everything, share with people. The more you share, the better output you get. Think about the Windows operating system and the Linux, The other one is closed, the other one is open. Which one performs better? It's a no-brainer. I don't know if that answers your question.
Thanks, Doc. It does. Thanks a lot.
Appreciate it, man. Thanks.
Okay. Thank you very much. Next up, we have Kulisani. Kulisani, go ahead.
Good evening, everyone. Yeah, quite an interesting talk, Martinowski. Actually, what makes me happy is that you are seeing you as a young person talking like this. What disappoints me now is mostly that the education system, especially in Africa, is not really empowering young people. The education system is more, I'm sure you remember, even when we were in class, what we used to use the oldest microprocessors that were invented maybe in the 1960s.
1842.
You get it. So, and actually, I'm just taken back to my time when I was doing my project. I remember presenting my proposal for my autonomous car. And what my professor, not my professor, my lecturer or supervisor actually said was, where are we going to use this? What's this for? Because the guy wasn't thinking ahead. He was supposed to be directing us, but the guy was actually lost. And I pushed and I did that project. And surprisingly, a few years later, I visited China. When I went to the HQ, Huawei HQ, I found the same concept that I had for automation being used. Actually, the whole factory with these automated robots moving things around. But that's something that also we had as young Africans, but we did not get that support. I'm not sure if there are programs that are in place maybe for the lecturing fraternity to try and change the way our universities are conducting this more academic approach instead of the more practical kind of approach.
Yeah, no, look, I think we've, I think in our boys group, we've basically talked about this, to some extent, and we've shared some views. So what needs to be done really, I mean, naturally the system will take care of some of the old stuff and the chaff that is in the system. But what we need to do more now is collaborative work amongst ourselves as young as we are, because Mark Zuckerberg is like, 3-4 months older than me, but is running a multi-billion US dollar company, and back then we were busy solving Frobenius equations and Laplace transforms and all that necessary complicated stuff. We didn't think about building the future of Africa, but it's not too late. It's not everything. Not everything is lost. Now that we've seen the light, we've got a better script. I think out of this, platforms like Zimnog, it shouldn't just be us talking here. After this, we should caucus in our different spheres and everyone look at who is doing stamps that you actually might be interested in. And let's take Africa to the next level. I believe Africa will be, they say 40% of the world's most productive workforce by 2025 will be in Africa. That's why you're seeing investing a lot in Africa, Twitter, Facebook. Why are these guys investing in Africa? Because they know the future is Africa, but we're not seeing that.
I totally, in the interest of time, we'll just take up one more question from Tsepiso, and we'll just allow you, Dr. Nkomo, to give a brief answer. We'll continue to have an iteration of these sessions, so don't worry. And he's available. So for those of you who have got more questions, we'll make it possible for you to reach out, and we'll create that platform for you to do so. So go ahead, Tsepiso.
Thanks, Nomsa. I have a really quick question. Just in light of, firstly, thank you for this meeting, and thanks, Doc, for sharing all your information. I just have a quick question regarding especially that you're focusing a lot on Africa and a lot of really innovative ideas from say the whole group, even just you, Doc. But I want to know, how do we now go back to the same societies where we are first and maybe second generation graduates, and we have to convince and maybe share with those people that, hey, this is an innovative idea, this actually works, this will be for the better of their lifestyles even. So how do we then go back and plant those innovative ideas in our hometowns? Because at this point, most of like the families and maybe friends from those societies believe that they're taking away, the fourth industrial revolution is taking away their jobs, etc., etc. So how do we tackle that?
Now, unfortunately, the one biggest challenge that we have at the end of the day as Africa is we always have to deal with bread and butter issues first before we think about innovation, right? By that, I simply mean a young graduate who has got an opportunity to innovate doesn't have the opportunity to innovate. Why? Because he's going to have to spend a lot of time trying to do black tax, taking care of his family, which is legitimate, which is not bad, you know. But to even go and motivate a child, like how do you go on and tell a child to say there's fourth industrial revolution when there's no water? You know, think about the situation happening in Zimbabwe. You know, there's no water, but you can't be telling people about the fourth industrial revolution when there's no water at all. The single most basic thing anyone can ever do. I mean, talk about electricity, you know, stuff like that. So what we need to, we might consider, it might not be the solution and everything, you know. I think we need to find ways in our communities. I'm always intrigued by the idea that when you step out of the house, you know, the solutions that you see in your area should be locally built. You know, by that I mean to say, when you step out of the car, you know, the cars that we drive, you know, most of them are from Japan. You know, they're not even from here. You know, so we need to start building.
Okay, thank you very much. I hope that has answered your question.
Thank you.
Just to wrap up, I'm sorry we've run out of time. We've gone above and beyond the time that we set for the session, but it was that interesting. And we encourage you to continue to give us feedback. We'll pause the session for 2 minutes. The QR code will be on the screen. If you cannot scan it, you can use the link on the chat section, which is at the right side of your screen. And then after that, we will hand over to Cuthbert, who will announce the winner and close the session.
Hello, sorry, I lost you there, guys.
Hi, Marlvin.
Yes, sorry.
We have just paused the session for 2 minutes to give people a chance to give us some feedback. We will be returning next 2 minutes to announce the winner to close the session.
Okay, sorry. I also I think my computer power died out. I think I didn't realize I wasn't connected to the mains power.
Okay, no problem.
Yeah, I've switched on to a mobile device. I'm sure you can hear me.
Okay, yeah, we can hear you.
Yeah.
It's that power problem you mentioned with the sensors.
I think this one was an irresponsibility on my part.
It's not a problem. We're human enough to know that some things just happen. I mean, even in the best meetings, we've seen very, you know, funny things happening. So it wouldn't be the first or the last. So I think we've given you time, guys. I'm just going to switch over the screen and you can look for your name if you've given us feedback. These are the names of people that have actually given us feedback. And so I will be starting the randomizer. Cuthbert will, I'm going to hand over the session to you now. Cuthbert, you can go ahead.
Okay. Can you start the randomizer? Anyway, I just want to thank everyone who participated. Us as Zimnog, we host most of these things, you know, basically every month, so that we keep each other, you know, motivated. Every time I'm always learning something. I thought I knew IoT, but today, trust me, I knew something. I have learned something new. So I would like to thank Dr. Nkomo for such a wonderful presentation, and thank everyone who sacrificed their time, you know, to attend with us. And I hope we'll be able to, you know, link with each other even more. If you have any topic you want to present, please feel free to, you know, to contact us in advance, and we can arrange, put up a platform so that you can gain an audience and teach, educate one another. You know, as people who are in IT, we have to motivate each other and feed the society, help the society, and bring out the best outcome out of the knowledge that we have gained from learning. So I think that will be it. And I don't know, Nomsa, if we have a winner as yet.
Yes, we do.
That's samty@gmail.com, right?
Yes.
Okay, wonderful. So congratulations, we have a small package for some, I don't know the actual name, I'm seeing the email address only. So we have to...
we will be able to find your details on the form you filled in, and we'll reach out to you. It's a small price. You should know, all of you, that this community is run by volunteers. There is no one that's paying money in, or there's nothing, everything is pro bono. So this is why we say it's a small little gift coming from volunteers like yourselves and I to facilitate for this. Thank you. Over to you, Captain.
Okay, thank you, Nomsa. And congratulations once again to SAMT. I hope you enjoy the little token that we have for you. And then, guys, as Mr. Nube said at the beginning, there's going to be another IoT presentation. I think in 2 weeks' time, there will be another presenter who will show us the other side of IoT. You are all free to join us. There's a meetup page that we normally post. Our website is currently under construction, but hopefully in a week's time, it will be done. But up until then, thank you very much. Thank you for your attendance. I wish you a wonderful evening. Thank you.
Thank you so much.
Thanks, guys. Appreciate it.
Okay.
Cheers.
Cheers.
Okay.
Thank you, everyone.
Cheers, guys. Thank you.
Okay.
Cheers, guys.
Thanks, Mike. Thanks a lot. Thanks, guys.
Okay.
Thanks, Marvin. Great chat.
Thank you.
Thank you.
Thanks, guys, for hosting this. Thank you so much, Namsanti. Enjoyed. I joined late, but yeah, definitely it was Cuthbert. Thanks a lot.
Thank you, everyone. Yes.
Cheers.
So,
Again, I
Thank
think I
you for
can
your
terminate.
support.
okay. Thanks, guys.
Community is ours, so let's continue to learn and share. And anyone who's got time and content that's valuable, as what Dr. Nkomo said, you know, it's just about putting our efforts together. We never know what we might come up with.
Yeah, collaboration efforts, right?
Sure.
Yes. Sure.
Okay, thank you.
All right, cheers.
Cheers, bye.